Today we are going to discuss about simplex method. So in this lecture, first we are going to discuss about what is the working procedure, means what are the steps involved in simplex method and how to carry forward those things. Then second is that the flow diagram of simplex method, so which will simplify the algorithm in a better understanding. And third, we are going to see about some example problems on that, means using simplex method how to solve some real life problem. And finally we will see some practice set, that means we have some problems that you can do and get some confidence over this simplex method. So let us start with the first section, that is working procedure. So here the steps we need to understand thoroughly, then only we can apply in a better sense. So the step 1, what it says, step 1 says that check whether the objective function of the LPP is to be maximized or minimized. Okay, so already in the last or previous classes we have seen that to apply simplex method we need to convert that LPP, we need to convert the LPP into standard form of LPP. Okay, after converting that we need to apply. So what is that, we will see. So objective function is very important in LPP. So if we have the objective function z is c1x1 plus c2x2 and plus so on plus cnxn, means linear combination of this decision variables x1, x2 and so on xn, and c1, c2, cn are the constants. And if the problem is given is to be minimized, okay, so then minimized problem can also be converted into maximized problem. For example, if you know the technique for maximization and the problem is asked for minimization, so then how to do, we can convert that minimization problem to maximization problem or maximization problem to minimization problem by multiplying -1. So -1 if you multiply with the objective function z, then you can convert minimize to maximize, maximize to minimize. For example, here it is given minimize z. So if minimize z we have given, so that is nothing but the solution, what we will get is nothing but the solution of maximize minus z. Okay, so this you need to be understand, because we are going to discuss further the maximization problem. So if minimize will come in the question, so that you can multiply with -1 means with z and you can find out the maximized problem. So that will be minimize, you can find out. Okay, now check whether all b's means right side constant of the constant. So whenever we see the standard form, so standard form will be like this, means a11 x1, for example I am writing a11 x1 plus a12 x2, okay, equal to b1, it was there. So b1, this constant should be what, positive. If any of the bi's is negative, then if we have negative, then we have to convert it into -1, means you have to convert into positive by multiplying -1. Okay, then only you can start. Understand, this bi or b1 here is need to be positive. Next is that step 2. In step 2 we need to express the LPP in the standard form. Okay, convert all inequalities of the constants into equations by introducing slack or surplus variable in the constant. So constants will be in the form of less than equal to or greater than equal to. So what to do, for less than equal to we need to use slack variable. Okay, for greater than equal to we need to use surplus variable. So if you add a slack variable and surplus variable, then only the inequality becomes in the standard form. So after doing that we will go to the step 3. So step 3 is very important, means if the LPP involves m equations and n unknowns, as already I have seen that we have seen if greater than equal to or less than equal to will be there, we will add surplus variable, we will add slack variable. So adding surplus and slack variable, what happens, you will get the number of equations which will be less than equal to number of unknowns, because that time whatever unknown will be provided, along with that the slack variable or surplus variable will be added. So along with that, if you see, so there will be how many, the unknowns will be more than the number of equations. That's why we will consider n is greater than m. Okay, when number of unknown is greater than number of equations, then what to do, we have to assign 0 value to any n minus 1, n minus m of the variables for finding solution. Understand? So if we have a11 x1 plus a12 x2 plus a13 x3 equal to b1, a21 x1 plus a22 x2 plus a23 x3 plus equal to b2. So how many equations? So m equal to, you have 2, n equal to 3. So in this case the difference is what? 1. So in that case the extra variable what you will get, that you have to assign 0 value. Okay. So start with a basic solution for which xj means 1, j equal to 1, 2, 3 up to n minus m. Basic variables means basic variable always will be less than, you see, basic variable you have to choose and then non-basic variable. The variable which you have to make it 0, that will be non-basic, and other variables will be 0. Okay, so find all SI values are 0. SI value means here whatever slack variable or surplus variable. Okay, in the objective function, when, like for example, if you have two inequalities, okay, and you are adding two slack variable, so in objective function there will be no slack variable. So what you can write in place of that, you can write 0, 0. So S1 and S2, if you have two slack variable for two constants, so Z will be, if you have C1 x1 plus C2 x2, so this you can write it as, here I will write it, Z equal to C1 x1 plus C2 x2 plus 0 into S1 plus 0 into S2. Okay, so this is the way we can represent the objective function. So which we will see those things. Now after doing that, the first thing is that you have to construct the table. So how to construct the table, that I will say. So when you will write this like a11 x1 plus a12 x2, okay, so all those things, the coefficient of x1 x2, okay, in first constant, that which will be converted into equation form, and the coefficient of x1 x2, okay, that will be converted into equation form. So the coefficients are written like this: a11, a12, a13, okay, a21, a22, a23, like that. Understand? And the objective function, if you have objective function z equal to c1 x1 plus c2 x2, so this coefficient you can write under here, means cj is c1, c2, c3, okay, like that it will be proceed. Understand? Now the slack variable will be like first equation, the slack variable, if surplus value variable if we have, then s1 we have write like this 1, then s2 will be 0 because there will be no contribution, s2 for equation 1, then s3, similarly second equation, third equation, in that way you have to fill. And next thing is that you can start, you will start with this s1, okay, s2, s3, means s1 coefficient will be 1, so basis will be s1, s2 will be 1, s2, s3 will be 1, s3 we have to write, and the corresponding s value the corresponding the objective function, the coefficient will be what? S1 coefficient, what I have written here, 0 into S1 plus 0 into S2. So like that, whatever surplus and slack variable, their contribution in objective function will be 0. So that you have to consider here 0 0 0, means the variable which you have to take as the basis variable for their contribution in objective function, those coefficients you have to write. Okay, 0 0 0. Now this matrix is called your body matrix, and when you consider the basis matrix will be your unit matrix. Okay, clear? And B is called your right side vector. Okay, like B1, B2, B3 and so on, those things. So next we will discuss all those things in detail. So whatever I have told, those things are there. Like here the variables x1, x2, x3 are called the non-basic variables because we are not considering as basis. Okay, and variable s1, s2, s3 are called basic variables. So what is the procedure we have? So if we have like optimization, if we have the region this, so what we do, we start, generally the idea is to start from one point, this P1, and let it be Pn point. So we have to reach the point, okay, P1 to Pn, like that if it is going. Okay, if we are searching like this P1 to this point, then this point, then Pn. Okay, so we are finding from P1 to Pn. So we have to start with some point, then what will be that point? Okay, so we have to consider that point as S1, S2, S3, whatever the slack variables are there, those variables we are taking as basic variable, and whatever x1, x2, x3, all those values we have to take as 0. Means we can say that we will start from origin. Okay, from origin we have to start the search, and we will update the process and we will get the best point. Okay, so that is the idea behind that, and we will implement those things. Refer to the basic variable s1, s2, s3, etc., and Cj rows denote the coefficient of the variables in the objective function that I have told. The Cb column denotes the coefficients of the basic variables only in the objective function. The B column denotes the value of the basic variables, while remaining variables will always be 0. The coefficients of x, that means decision variable in the constant equations, constitute the body matrix, while coefficients of slack variables constitute the unit matrix. So we will see all those things in more detail while we will solve the example problem. So fourth step is the optimality test. As we have discussed in the previous classes, that simplex method will be based on your optimality test, and another is feasibility condition. So optimality test and feasibility condition. Now what to do under this? So we have to compute this value Cj equal to small cj minus zj. So small cj, that we know, these are the coefficients we are getting from the objective function, and zj we have to calculate like this, summation of cb into aij are the coefficients. So we are going to see those things in detail while we will solve the problem. So Cj, capital Cj is called the net evaluation row, and it indicates the per unit increase in the objective function if the variable heading the column is brought into the solution. If Cj are negative, then the initial basic solution is called optimal. So this is the what? This is the in the case of maximization problem, we will have Cj, and Cj is negative, then what we are getting, the solution will be optimal. If even one Cj is positive, what to do? If Cj is positive, or there are number of positive values for Cj, or at least one positive value, so we have to go with the positive value to find the next best point. So how to do that, that also we will see, but here if we have even one Cj is positive, then the current feasible solution is not optimal. So we need to improve the solution, that is it can be improved and proceed to the next step. Understand? So how to do that? So that we are going to see in the next steps. So identify the incoming and outgoing variables. So step 5 is very important. Based on the capital Cj value, we have to identify that which basic variable will go and new variable will come. That's why it is called identify the incoming and outgoing variable. So if there are more than one positive value, so here is the case, if one positive value is there for Cj, you take that one, that column. Okay. If more than one positive values are there, you have to take the most positive value. That means then the incoming variable is the one that had the column containing maximum Cj. So the maximum Cj value, whatever column we have, so that we have to see which column will head, and from that column we will extract which variable will be the incoming variable. The column containing it is known as the key column. So the column which will identify by the maximum positive Cj value will be called key column, which is shown marked with an arrow at the bottom. So we will show those things. Okay, while we will calculate in the table, we will show those things through arrow. Okay, if more than one variable has the same maximum Cj, then what to do? Any of this variable may be selected arbitrarily as the incoming variable. So if same value you are getting, so any of the variable you can take and start, but try to take the first one so that some homogeneity or the uniformity will be there. Okay. Then divide the element under B column, means next is that we have to find out the ratio. Okay, just remember in the previous lectures we have discussed about ratio and all. So those concepts are useful here. So divide the elements under B column. So B column we have to see by the corresponding element of the key column. So we have to divide the B column element, means Bi by A11 or then B2 by A21, like that we have to see. We will see in this when we will solve the problem. Then after getting the ratio, we have to choose the row containing minimum positive ratio. So again we have to see the minimum positive ratio. So we are dealing with maximization problem, that's why it is always we are taking the positive value for considering. There positive maximum Cj we are choosing, and ratio we are taking positive minimum. Okay. Then replace the corresponding basic variable by making its value 0. So we will see those things. It is termed as a outgoing variable. So first let us understand those things, then it will be clear. The corresponding row is called the key row. So one is key column, another is key row. So intersection of this will give you the element that will be the key element. Okay, which is the shown marked with an arrow. Again we will mark it through arrow on its right hand. The element at the intersection of the key row and key column is the key element, which will play the important role for finding the next best solution, which is shown in bracketed. Okay, we will show this thing in bracket form. If all these ratios are less than equal to 0, okay, the incoming variable can be made as less as you want without violating the feasibility condition. Hence the problem has an unbounded solution and no further iteration is required. So this point you need to understand, this is a special case. Okay, if all these ratios are less than equal to 0. So what I have told, when you find key row, that time ratio is important. So ratio is positive we are taking, so minimum positive value. So for example, if you are taking negative, if you are getting negative value, all the ratio are negative, then the incoming variable can be made as large as want without violating the feasibility condition. Means feasibility condition will not, I have shown you that it will be in unbounded region. For example, if this is the case, okay, maybe if this is the region, so it will not violate the feasibility condition, it will be greater than, feasibility condition is xi greater than 0, okay, it will not violate this, it will obey this thing, this condition, but the thing is that it will be as large as, it will grow, okay. So hence the problem has unbounded solution and no further iteration is required. Understand the concept. When you are finding maximization, so we have to see positive. So for Cj, okay, most positive, and for ratio R I can write minimum positive, okay, those things you have to take. But if minimum positive is not there, so whatever it is there, like we have to see. But if all are negative, then that time this special case will come. Understand? So next step we are going to see that iterate towards an optimal solution. Drop the outgoing variable. Now whatever we are getting the x or new variable from the what key column, so that will replace, okay, and the previous one we will drop. For example, this, if this is the column and this maybe xi value is there and this is the row, okay, and here maybe si value is there, so si will be replaced and this x will be considered, okay. So this is the process we are going to see. So convert the key element to unity by dividing the key row by the key element, then make all other elements of the key column 0 by subtracting proper multiples of the key rows from the other rows. So we will see those things, then it will be more clear from tabulation. So last step is that go to step 4 and repeat the procedure until either an optimal or an unbounded solution is obtained. So means we will stop when Cj, all the Cj value will be what, positive, or negative, will be negative. So we will see negative for maximization problem and positive for minimization problem, then we will stop. So we will see that through your diagram it will be more clear. Now first we have to start the process. So convert the given LPP into standard LPP, okay. Decide the coefficient of the variables, objective function, construct initial table that we have shown. After that compute Zj and Cj. So if your Zj is positive, means Cj is positive, capital Cj, this one is positive or negative, based on that we have. So now here a decision is coming, is this LPP of maximization type or minimization type? If maximization type, just we have seen maximization type, then next question is that are Cj values are negative or 0? If negative or 0, then we have to do nothing, we got the optimal solution. Minimization problem, we have to see if the Cj values are positive or 0. If yes, positive or 0, then we got the optimal solution. But in maximization problem, what I have told, if the Cj value is positive, means if it is not negative or 0, then we have to proceed. See, that means we have to select the key column with largest positive C value, then we have to find out the ratio, we have to take the minimum of the ratio. After finding the minimum of the ratio, identify the key element at the intersection of key row and key column, then update and find out, and then again you have to go to find this step 4, that is you have to find Cj value and calculate. Simply in minimization also same, whether the Cj values are positive or 0. If no, means if your Cj values are coming negative, okay, then you have to proceed, find out the key element, then ratio, okay, then means key column, then ratio, then key element. After that you have to update the solution and you have to repeat till you are getting the best. So this is the procedure you have to understand. Okay, now we are going to discuss one example problem which will clarify everything. Okay, now properly understand the problem. We have given using the simplex method, maximize z equal to 5x1 plus 3x2 subject to the constants x1 plus x2 less than equal to 2, 5x1 plus 2x2 less than equal to 10, 3x1 plus 8x2 less than equal to 12, and x1 x2 greater than equal to 0. Now what we will get from this problem, we have to find out maximization type of problem. And what are the Cj value? 5x1, 3x2. So here I can write this small Cj means C1 equal to 5, C2 equal to 3, yes or no, because we have C1 x1 plus C2 x2 objective function. Now the first constant we have to see, the first constant is x1 plus x2 less than equal to 2, that means if we add some variable then it will become equal. So we can write x1 plus x2 plus one slack variable, that is s1 equal to 2. Fine. Now for second equation we have also less than equal to sign, so that you can convert into 5x1 plus 2x2 plus s2 equal to 10. Now third equation also is in terms of less than equal to, so that you have to write 3x1 plus 8x2 plus s3 equal to 12. So here you can see again this b value 2, 10, 12 all are positive, so done, no issue. But the thing is that we can convert this thing in different way. Now what we can write, x1 first equation as x1 plus x2 plus 1 into s1, that is s1 plus 0 into s2, because s2 contribution is 0, plus 0 into s3 equal to 2. So that is the first equation we can write. Second, we can write 5x1 plus 2x2 plus 0 into s1 plus s2 plus 0 into s3 equal to 10. Fine. Next, we can write 3x1 plus 8x2 plus 0 into s1 plus 0 into s2 plus s3 equal to 12. Okay, we can write like this. So here we represented the constant into equation form in this way, whereas the maximize z equal to this objective function we can write 5x1 plus 3x2 plus 0 into s1 plus 0 into s2 plus 0 into s3. Yes, clear. So all this now Cj coefficients are what? C1 is 5, C2 is 3, C3 is 0, C4 is 0, C5 is 0. Now the coefficients are what? Here coefficients we will get A11 is 1 because 1 into x1, A12 is 1, A13 is 1, then 0, 0, A21 is 5, A22 is 2, A23 is 0, like that we will find out. So using this we will construct the first initial table. Okay, let us see how to do. So those things whatever we have discussed, that we have converted and written here. So this is the maximize and this is the objective function, new objective function, modified one, and these are the equation, first equation, second equation and third equations. Now we will start the table. Now you see the table is, we have to write the first body matrix. So in the body matrix we have x1, x2, s1, s2, s3 as the variables. So for x1 the objective function contribution is 5, okay. For x2 the objective function contribution is 3, and s1 0, s2 0, s3 0, okay, clear. Now from the equation what we have, 1x1, 1x2, 1s1 plus 0s2 plus 0s3 equal to 2. So that we have to write in this form. So a11 will be 1, a12 will be 1, a13 will be 1, a14 is 0, a15 is 0, then b right side vector. Similarly for the second equation, 5, 2, 0, 1, 0, 10 we have to write. Third equation is we have 3x1 plus 8x2 plus 0s1 plus 0s2 plus s3 is there, that is why we have to write the coefficient 3, 8, 0, 0, 1 equal to 12, okay. So that we have to write in this way. Now after that, the first thing what I have told you, that we have to select the basis variable, and the basis variable is nothing but the slack variable or surplus variable what we have taken, that we have to take. So slack variable first one is s1, second is s2, and third is s3 you have to take, and cb denotes the objective function. From objective function whatever the coefficient of those variables, coefficient of s1 is 0, this one we are getting, okay. Coefficient of s2 is 0, so this we have taken here, and coefficient of s3 is 0, so this we have taken, clear. Now after doing this thing, next thing is that find out zj value. So zj is nothing but the summation of cb into aij. So this is our a11, a12, a13, a14, a15, okay, a21, a22, a23, a24, a25, a31, a32, a32, 33, a34, a35. So in notation form we had like this, and this is the form. Now zj how to calculate, summation of cb aij. cb aij means this. So 0 into a11, this 0 into 5, 0 into 3 we have to add. So 0 into 1 0, 0 into 5 0, 0 into 3 0. So if we add it will be 0. Then this one, this one. So 0 into 1 0, 0 into 2 0, 0 into 8 0. So like that we can find. Similarly we have to find this cb, this one, okay. Then this one 0 into 1, then 0 into 0, then 0 into this 0. So we have to add all these things after that, so we are getting 0. Similarly we will find this one, this value and this value, and the next one is 0 into 2 0, 0 into 10 0, 0 into 12 0. So if we add all those values, then we will get 0. Now after getting zj value, next thing is that to calculate capital Cj value. How to find out the capital Cj value? So capital Cj value is nothing but your small cj minus zj, okay. So small cj is coming from here, so 5 minus this, so 5 minus 0, this one, so we are getting 5. 3 minus 0, so we are getting 3. 0 minus 0 0, and all other values we have to compute, okay. After computing this thing, we have to see whether it is a maximization or minimization type problem. So maximization type of problem, so maximization type of problem we have to select the column in which we have the highest positive value. So here we have 5 and 3, and 5 is the maximum. So this we have to consider, which we have marked through arrow, this arrow. So this column, okay, this column we have to take. Now in this column we have to find out the ratio. Now ratio, how to find out? This is the B value. So B value by this one. So 2 by 1. Next B value 10 by this entry 5. So 10 by 5. Then 12 by 3. 12 by 3, that is 4. And then we have to see the smallest positive value from the ratio. So this is the ratio. So 2 by 1, here also 2, here 4. So here 2 is there. So for uniformity, what I have told, you can choose any of the row from here, but for uniformity take the first one. So if you take the first one, so this row will be considered. So this row and this column will intersect at this point 1, which will be the key element 1. Okay. Next thing is that we have to make it 1, means this element value is 1 itself, that's why no problem. But if instead of 1 it is maybe 5, okay, if 5 is there, then we have to divide this. If it is row 1, so we have to divide this row 1 by 5 to make this key element unity. Understand? Once this you can make unity. Okay, next is that you have to replace. That means x1 is the new variable is coming. Okay, from this column it hits x1 and from this row it hits s1. That means s1 will be replaced by x1 and this key element will be 1. After that, what to do? Below to that all other entries we have to make it 0. Means S1 contribution is here is this. You see, if you see the unit matrix, this is the unit matrix, yes or no? So in this unit matrix, S1 is representing the 1 0 0 column. That means when S1 will be replaced, X1 will come in place of S1, okay, then the column will becomes 1 0 0. If S2 is replaced, then what to do? We have to make the column in such a way that the key element will be 1 and above and below it will be 0 0. Okay, if S3 will be replaced and a new variable will come, then the key element will be 1 and other elements means above to 1 it will be 0 0. So that is the concept. Okay. So next we are going to see the updated table. After changing all those things, what is happening we will see first, then we will see the updated table. Now when we saw this, now you see x1 variable is coming, okay, in place of s1 and the elements and the row is 1 1 1 0 0 2, okay, and s2 is like you have to what I told, you have to make it 0. How to make it 0? You see, if this is row 1 I am telling, and this is if row 2, this is row 3. So you have to do the row operation. So if it is there, then you have to change R2 as R2 minus 5 R1. So if you do that, this element will be 0, means 5 minus 5 0. Then next row operation you have to do is that R3. So R3 will change to R3 minus 3 R1. Okay, so if you do that, then this 3 entry will be 0 and all other entry also simultaneously changes. Okay, now the second one if we see, so if I do this, so second row I am writing second row will be what? This 5 minus 5 it will come 0, this one, then 2. Second one will be what? This is the first entry. Second entry will be 2 minus 5 into 1, that is minus 3 will get this one in place of this. Now third entry 0 is there, so we will get 0 minus 5 into 1, that is what? Minus 5. Similarly here next entry is 1, so 1 minus 0 into 5 equal to 1 will get, then last one you will get 0. Then here 10 minus 5 into 2, that is 10 minus 10, again 0 you will get. Okay, so those way you will find, and the next row also you will find. You see, we are getting 0, minus 3, minus 5, 1, 0, 0, yes or no. Similarly, you can find out the next row. Okay, so this is the form. After getting this thing, next thing we have to see the ZJ value. So ZJ value, all the ZJ value we are getting this 5, 5, 5, 0, 0, 10. Next thing you have to calculate capital Cj. Capital Cj will be small cj minus Zj. Okay. So here you can notice that once the basis variable will be replaced, means in x1 is coming as a new variable. That's why the coefficient of x1 is 5. Okay, in objective function. That's why the 5 will be replaced in place of 0 here in CB column. Okay, so Cj will be small cj minus Zj. So we will get what? The small capital Cj is, first you will get 0, second one you will get minus 2, third you are getting minus 5, 0, 0. That means all the values are either negative or 0. So if you are getting negative or 0, then that means you got the optimal solution. And what is the solution? Optimal solution. This is the optimal Z value. Okay, and for what combination you are getting? You see 5x1, so B is 2, and 0 S2, 0, 0 S3, 6, means you are getting 5 into 2 plus 0 means 3 into 0, you are getting this thing. So this is solution. 5 into 2, what? 10, because we have 5x1 plus 3x2, 5x1 plus 3x2. So x1 is what? Here 2, x2 is what? Here 0, and s, there will be no contribution for s because those are the variables we have introduced to solve the problem. So we are getting the solution as 2, 0. So 2, 0 is the solution, and the optimal Z value will be 10. Okay. So this is the procedure. I hope it is clear to you. Now there is another problem we have. Okay, example 2, so that you can try it. Okay, whatever the solution is coming, just try. Here you may get more number of tables depending on the capital Cj value. You just try and see how it will come. So the solution is here. We have, just I am showing the solution. Again it is a maximization type problem, so you have to convert it into proper form. Then you have to write the matrix. This is the first matrix, and you have to select Cj, means key row, key column. Okay, and you have to identify the key element which will be given in bracketed form. Okay, after getting that, you have to construct the next table. Okay, so next table you are getting here. This table also we are having. So from this table you can find out the again key row, key column. Okay, here you can see key row is x2 row, and sorry, key column is x2 column, and key row is s1. So s1 will be replaced by x2, and similar way we have to find out till you are getting all the Cj values are negative or 0, means capital Cj value. So here we are ending, because here we are getting the negative value or 0, and this is the optimal solution we are getting. So this way you can get the solution for maximization problem, and you can convert minimization problem to maximization problem by multiplying -1 with z, the objective function, and get the solution. So I hope all these things are clear. If it is clear, you can see some practice set also. You can solve those problems to get some confidence. these are the references I have used. You can take those references